Section 4.6, Congruence in right triangles. The hypotenuse is the side opposite the right angle in a right triangle. So the hypotenuse is the side opposite the right angle in a right triangle. It is also the longest side of that triangle. The legs of a right triangle are the two other sides of the triangle. So far we've learned side, 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 angle, side, and angle, angle, side to prove triangles. Congruent. But today we're going to look at proving right triangles congruent through the use of finding a pair of right angles, a pair of congruent hypotenuses, and a pair of legs. And this is going to lead us into the next slide, which is going to introduce us to the HL theory, or theorem, which is the hypotenuse leg theorem for proving two right triangles congruent. So, Theorem 4.6 is hypotenuse leg, or HL theorem. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So in reality, you need three things. You need congruent hypotenuses, congruent corresponding legs, and you need both triangles to be right triangles, so they both have to have right angles in them. Once you know these pieces, so 1, 2, and 3 for each triangle, you can prove the two triangles congruent using HL theorem. So like I said before, in order to use this, you need three things: right triangles, congruent hypotenuses, and one pair of congruent legs. On the basketball backboard brackets shown below, ADC and BDC are right angles, and AC is congruent to BC. Are the two triangles congruent? Explain why or why not. So I'll sketch this so it's a little easier to see. So we'll resketch this to make it look a little nicer. So ADB and then C's here. We know we have a right angle here and congruent pieces here and here. So what we know is if this particular angle BDC is a right angle, the one beside it is also a right angle. So we have two right angles, hence creating two right triangles. And these two sides that are already marked congruent are our hypotenuses. So right now we have the hypotenuses, we have the right angles, but we need a congruent pair of legs. Well, we should notice that DC is congruent to itself by the reflexive property. So now we have more than enough information to go ahead and say that these two right triangles, in this case ADC, is congruent to triangle BDC by HL theorem, or hypotenuse leg theorem.
Green.
Here we're introduced to our first proof. Given that angle PRS and RPQ are right angles, and we're also given that SP is congruent to QR. So with most of the proofs we do, we start with our given. So PRS and angle RPQ are right angles. So that's given. We also know that SP is congruent to QR, and that's given as well. So from there, we then need to figure out what else we need to try to maybe, in this case, use hypotenuse legs. So we have right triangles, we have the congruent hypotenuses, then we should notice that we have congruent sides in PR, because PR is congruent to itself. So PR is congruent to PR, and that's going to be our reflexive property. And then now I have a pair of hypotenuses, a pair of right angles, giving me right triangles, and a pair of legs. So this means that the triangles, in this case PRS, are congruent, and this triangle PRS is congruent to RPQ by hypotenuse leg theorem. for this one, we are given that BE bisects AD at C, and that AB is perpendicular to BC, DE is perpendicular to EC, and that AB is congruent to DE. All right, and we're trying to prove that these two triangles are congruent. All right, and so let's plan on using hypotenuse leg here. So we're going to start off by stating our given. So BE bisects AD at C. And then we're going to write the other half of the given on this line. AB is perpendicular to BC. DE perpendicular to EC. And we also know that AB is congruent to DE. And so that's all of our given. So given there and given statement there. And now we look at what we have. They've given us a congruent set of legs. And they've given us, the perpendicular tells us that we know that B and E should be right angles, but it doesn't explicitly say that. So that's going to be our next step. We're going to go ahead and say in this step that angle B and angle E are right angles. And this is definition of perpendicular. Okay, definition of perpendicular. Now, if we go back to the given, we have the word bisects here, and so we probably should use this somewhere. So if BE bisects AD at C, that means that BE is cutting AD into two equal parts. So that means AC should be equal to CD. So in this case, we can say that AC congruent to CD. And that's definition of bisector. Now that I have that, I have a pair of hypotenuses, a pair of right angles giving me right triangles, and a pair of legs. So my last step, the two triangles are congruent. In this case, triangle ABC is congruent to triangle DEC by hypotenuse leg theorem. Here we're asked, are the two triangles congruent? If so, write the congruent statement. So if we look at this particular set of triangles, number one, we know that these two hypotenuses are congruent because they're both measure of 10. And they've got congruent legs here and here. And we've got right angles. So these would be congruent by hypotenuse leg. So we're going to write our congruent statement. So I've got triangle ACB is congruent to triangle DFE. Question 2, we're looking to see if they're congruent. Well, vertical angles tells us that if this angle here is a right angle, this angle here is also a right angle. So once again, these are congruent by hypotenuse leg. So triangle MLP is congruent to triangle MON. Question 3, we cannot prove these congruent because we don't know about we don't know if there's a right angle or not. So, like I said, these two triangles aren't going to be congruent because we can't assume that these are right angles. So this is not enough info. And then in question 4, we've got congruent legs, right angles, and then we can determine that the hypotenuse here is congruent to itself by the reflexive property. So these two triangles are congruent. So triangle RVX is congruent to triangle RVT. For what values of x or x and y are the triangles congruent by hypotenuse leg? So keep in mind with hypotenuse leg, that would mean certain parts of the triangles are congruent. So in this particular first problem, This is the right angle, so this is the hypotenuse. With this being the right angle as well, this is the hypotenuse, so they should be equal. So all we're going to do is set the two equal to each other. And so in problem 1, we get x to be 17. In question 2, once again, we have the 13 as the hypotenuse, the x plus 1 is the hypotenuse. So we're going to start this problem by solving for x. So we'll take 13 equals x plus 1. We'll subtract 1, and we get x equals 12. Once I know what x is, I'm going to plug it back in for x in the other two problems. So in reality, these are going to become 2 times 12 is 24, so I've got y plus 24 instead here. And now I've got 4 times 12 is 48, so I've got 48 minus 2y. The other part of this that I know is that these are the congruent legs for hypotenuse leg. So to find y, I'm merely going to set those two statements equal to each other. So y plus 24 equals 48 minus 2y. To solve this, I'll add over the 2y, so I've got 3y. I'll subtract 24, and I get 24 on this side. I'll divide both sides by 3, and I get y equals 8.